This is a very interesting slide because it gives a holistic picture about the Six Sigma methodologies. And we're going to learn that there are three methodologies. The first one is DMAIC. DMAIC is an acronym for Define, Measure, Analyze, Improve, and Control. And this is a methodology that we typically use in order to improve existing process, existing products, and existing services. A variant of DMAIC is what is known as DFSS, which is an acronym for Design for Six Sigma. This is the Six Sigma methodology that we use when we want to either design new products, new services, or new process from scratch because they never existed, or we can use it in order to redesign and re-engineer existing process that do not meet customer requirements and customer specifications. Finally, we have the process management, and this is the methodology that we use in order to control and manage cross-functional process across the organization. Here we can see the contrasting between two of the main methodologies of Six Sigma. DMAIC, the one that we use for continuous improvements, for improving existing process, products, or services, and DMADV, the one that we're using to either create new processes, new products, and new services, or re-engineer existing process, products, or services that do not meet customer requirements and specifications. What we can say is that the first three phases, define, measure, and analyze, are common for both methodologies. And at the end of the analyze phase, we may decide that we want to improve, for example, the process, in which case we proceed with improve and control, or we may decide that the process is candidate for re-engineering, in which case we have to design and validate. Let's start with DMAIC. DMAIC is the classic Six Sigma methodology for improving existing process, products, and services. And as you can see, DMAIC is an acronym for Define, Measure, Analyze, Improve, and Control. These are the 5 stages or 5 phases of this methodology. So during the define, we define the problem. And this means that we have to fully understand what is the business problem that we're about to address. During the measure phase is we measure the current performance of the process and we baseline this performance. During the analyze phase, we analyze the data that we collected during the measure phase in order to identify root causes that create process waste. We move to the improve phase, and during that phase, we try to find solutions in order to either eliminate or reduce the root causes that create waste in the process. And finally, when we come to the control phase, this is all about monitoring the improved process for a short period of time, usually, let's say, 4 weeks, in order to make sure that it is stable in statistical control, it meets customer requirements, and it is ready to be handed over to the day-to-day operations. So, during define, we define the problem. This means that we have to create what is known as the problem statement. and also what is known as the goal statement or objective statement of the project. And we have to set up goals and objectives of what the project is about to achieve. During the measure phase, we measure the current performance of the process under investigation, and we validate the practical problem by collecting data based on a data collection plan. During the analyze phase, we analyze the data that we collected during the measure phase in order to determine the root causes that create the waste in the process. And also, this can be the starting point for thinking about opportunities in order to improve the process. Improve means that we find solutions, we pilot and implement the solutions in order to improve the process. And during the control phase we start actually using the improved process in the typical operating environments in order to determine that it is stable in statistical control, that it meets customer requirements and specifications, and also in order to determine if the changes that we made in the process had the desirable effects, in other words, what we were expecting. Along the way, the Six Sigma project manager, supported by the Six Sigma project team members, builds and organizes the team and also makes sure that roles and responsibilities are clear and understood by everyone within the team, defines what is known as the business problem statement that must be addressed, and also the objective or goal statement, what we try to achieve by completing the project, and basically creates the process control documentation. One of the key documents is what we call the project charter or team charter. And this contains all the basic information associated with the project. Works closely with the project sponsor and other key project stakeholders like the process owner and the managers of the business areas associated with the process to be improved. And finally, delivers results, because at the end of each phase of DMAIC, we have completed a number of tasks and we have produced a number of deliverables. These deliverables are assessed during the gate stage reviews, which are typically meetings between the project manager and key stakeholders. During these meetings, the project manager is presenting to the key stakeholders what has been achieved during the stage that has been completed and receives the approval in order to proceed to the next stage of the DMAIC project. This is the other Six Sigma methodology, DMADV. This refers to what we saw earlier as DFSS, Design for Six Sigma. There are 13 variants in Design for Six Sigma, but DMADV is the most common one, and this is the one that we're addressing in our course. So during Define, we define the project goal, what we try to achieve, and remember, Design for Six Sigma is either about creating a new product, a new service, or a new process that never existed before, or it is about redesigning, re-engineering an existing process, product, or service that does not meet the specified requirements. During the measure phase, we assess the customer requirements, which are very, very important. This is what the customer desires, and the project must meet all these requirements. During the analyze phase, we generate a number of different designs of the process, product, or service, and we select the concepts associated with these designs. During the design phase, we optimize the design and we complete the design of the process, product, or service. And finally, verify is about making sure that the quality, design, performance, etc. are as they should be. And also, this is when we implement the design. At the end of it, either we take a new product or service to the market, or we deliver an enhanced product or service. One of the main objectives of this methodology is to make sure that we embed Six Sigma quality in process, products, or services from the design stage. So, we talked about define, we determine the projects, we have to justify why there is a need for the project, and we set up the goals and the objectives that must be achieved. During the measure phase, we assess the customer needs and we prioritize the customer requirements. We analyze the data, we generate a number of different designs and associated concepts. We optimize the design components and we complete the design. And finally, we verify, validate, and quantify the design performance. This completes the DMADV methodology, which is the most common methodology of design for Six Sigma. Now let's have an overview of the DMAIC process. The DMAIC process improvement process is data-driven. This means that we collect data, we analyze data in order to come to data-based conclusions. It is followed in a strict sequence. This means that in each of the DMAIC stages, we have to follow a number of steps and we have to produce a number of deliverables. During the define phase of DMAIC, we collect information that it is already available for us. First, we have to understand the project particulars. In other words, what is the project purpose, the scope, the goal, the objectives, the deliverables, etc. The second step is we have to progress with process mapping. So, during the define phase, we create the current state of the process map. This is known as the ASSIS process map. We determine, based on criteria set by the business, if this process is a good candidate, for a DMAIC project. And something very, very important, which represents the voice of the customer or the voice of the client, as it is well known. We have to determine what are the critical customer requirements, and these are also known as CTQs, critical to quality requirements, and these are associated with the process outputs. We have to estimate how long the project is going to take in order to complete between start and finish, And also we have to estimate what are the associated costs in order to complete the project successfully. So let's have a look at the measure phase of DMAIC. So the objective of the measure phase is to have a good understanding about how the process performs in its current state before we make any changes in the process. So the first thing is typically we start with a set of research questions, the answers of which will help us determine, how we can solve the business problem. These research questions will formulate the basis in order to develop the so-called data collection plan. And in the data collection plan, we have to determine what type of data we have to collect, how frequently we have to collect them, who is going to collect them, and all the associated details with data collection. We have to decide what we're going to measure and where. And typically in a process there are 3 measurement points. We can measure at the input level, between the process start and the process ends, and also we can measure at the output level. We have to determine how we're going to collect the data, because data collection is a process on itself. This means that we have to make sure that the people collecting the data, they do this in a consistent way, which means that sometimes we may have to create, for example, a standard operating procedure or a work instruction about how we're going to collect the data, which steps the data collectors have to follow. We have to determine what is the level of the process variation in the process as it is at this point in time, before we make any changes, so we can understand how much or how little variation we have in the process. We have, using as a basis the current state's process map, we have to identify areas of potential waste, and we have to highlight them. Later, these are used as the basis in order to identify what kind of solutions we have to introduce in the process in order to solve the business problem. Once we have completed all this, we start collecting the data according to our data collection plan. And at this point, we also calculate the process capability. This is something that we're going to address a little bit later. But each process has 2 capability metrics. One is known as CP, which is, the potential process capability, and the other is the CPK, which is the actual process capability. The last thing we do during the measure phase is we baseline the current state of the process, and we're going to use this as a yardstick after we improve the process in order to determine by how far we have actually improved it, by how far we have improved the process capability. We're moving to the analyze phase, and this is, a very critical one, because so far we have understood how the process performs in its current state without making any changes. Now we have to use the data that we collected during the measure phase of DMAIC in order to determine what are the root causes that are creating the waste in the process. So the first thing is we have to identify the root causes of the identified wastes. We have to validate these root causes, and validation is very important because this is going to be used as an input in the next stage of DMAIC, which is the improved stage. We have to estimate what is the cost to the business of the identified wastes. This means we have to quantify the waste, and this is going to give us an indication of the operating cost savings that we're going to have once the process has been improved. Now, assuming that all the identified process wastes have been removed, this is something that we have to visualize. Based on this assumption, we can create, an illustration of the improved process, how the process will look like after all the identified waste has been removed. And of course, this is just an illustration. You can consider it as a strawman, or, just like, a typical model. And this is going to be updated after we have made all the improvements during the next stage of DMAIC. We have to estimate what will be the capability of the improved process, the CP, the potential process capability, and the CPK, the actual process capability. So let's have a look at the next stage, which is actually a very important stage. This is the first time that we're going to actually make changes in the process under investigation. Because until now, we collected data, we analyzed data, but we have not made any actual changes in the process. So, the two main inputs that we use during the improved phase of DMAIC are the validated list of root causes of waste that we created during the analyzed phase of DMAIC. And the second one is the illustration of the improved process. As I mentioned, we create an illustration of the process map, imagining that all the identified waste has been removed. So these are the two key inputs into the improved phase of DMAIC. So, the first thing we have to do is to make sure that we gather the process subject matter experts. We call them the process workers. These people are typically team members participating in a DMAIC project, and they have subject matter expertise about the process because they are running the process on a daily basis. Then the whole project team is brainstorming in order to come up with potential solutions. And speaking about solutions, we're referring to process changes that will help either eliminate or at least reduce the root causes that create the waste that we identified when we created the current state process map. So, from a long list of validated root causes, we come up with a long list of potential solutions. Now, in order to utilize these solutions, first we have to group them. And typically we group them in what we call quick wins, medium-term solutions, and longer-term solutions. Speaking about quick wins, these are typically process changes that are easy to implement, quick to implement. They do not require extra capital and require minimal level of resources. That's why we call them quick wins. Medium-term solutions, these are solutions that typically take longer than the quick wins in order to be implemented. Just to give you an indication, quick wins should be implemented between a few hours all the way up to 3 months. Medium-term solutions are between 3 months and 6 months. And long-term solutions, which are usually associated with process automation, they may last longer than 6 months. So the first thing we do, with the long list of solutions, we group them in quick wins, medium-term, and long-term solutions. The second step is to make sure that we set up criteria in order to select the best solutions. This will help us to prioritize within each of the 3 groups that I mentioned earlier. So typically we weigh potential solutions against the criteria and we come up with a total score and we prioritize them. Now, typically we have sufficient time in order to focus on the quick wins, because typically this is what we have enough time and resources in order to change in the process, in order to improve it. So we pick up the top solution in the quick wins and we carry out 2 steps. The first step is to pilot the solution in order to determine that actually it improves the process. And the second step is to implement the solution. Typically we do this by following the PDCA cycle: plan, do, check, and act. We do this for the pilot and we do this for the implementation. So, during the check phase, we measure the results of the test and we compare them to the measure phase data. So, if the pilot is successful, then based on the lessons learned, we repeat the PDCA cycle in order to complete the implementation of the solution. And we do this solution by solution by going through the list of the quick wins we identified earlier. So once we have completed all the process changes, once we have implemented all the selected solutions, then we have a very good idea about how the improved process actually performs. And with this knowledge, we can update any existing process documentation. For example, any standard operating procedures, any working instructions, any forms, reports, etc. So with this knowledge of the improved process, we go back to the illustration of the process map that we created in the analyze phase, the 2B process map, and we update it. Now, once we have updated the process documentation, we can use it in order to train the people that will actually operate the process once it becomes part of the day-to-day operations. So we create a training plan, we deliver the training using the updated process documentation, and the last thing we do during the improve phase is we create the so-called control plan. The control plan will be our blueprint in order to monitor the improved process during the final phase of DMAIC, which is the control phase. Now let's step into the final stage of DMAIC, the control phase. So we have already made all our changes in the process. We have trained the people that will actually monitor the process during the control phase. We have updated the process documentation. So the main objective of the control phase is to make sure that the process is stable. In other words, it produces stable and steady results in the process output. Stable process is also known as a process in statistical control. Second, we want to determine that the process changes, they had the expected results in improving the process as we had planned. And finally, we want to make sure that the improved process meets or even exceeds customer requirements, which are represented by the voice of the customer or the voice of the client, as we call it. During this phase, we have to determine how the improved process performs in a production environment. This means that we're going to run the improved process in a production environment which resembles day-to-day operations for a brief period of time, typically over a few weeks. So once we're happy that the process is stable and the results of the changes that we made are what we expected, then we standardize the process and we prepare it in order to be handed over to the day-to-day operations. So we have to plan how to do this handover. And speaking about day-to-day operations, this is typically represented by the process owner, which will become the custodian of the improved process. So we hand over from the project to the day-to-day operations the improved process and the associated documentation and the control plan. And this now is in the hands of the process owner, who will take custody of the improved process. At this stage, we have more or less completed the project. And because the project is no longer needed, the project manager or the project lead has to complete a series of project administrative activities, and upon completion, he or she has to go and request from the project sponsor approval in order to formally close the project. This is when the project is closed and all the key stakeholders are notified that this is a fact now and the process has been operationalized.